All right, everyone, we're going to get started. Fernando, do you want to kick us off?
Yes, thank you. So welcome everyone to the second session of the BITS Open Research Seminar. We're delighted that you could join us. I am Fernando Oces de la Guardia, a project scientist at BITS. For those of you who are joining a BITS event for the first time, the Berkeley Initiative for Transparency in Social Sciences was established in 2012 to improve the credibility of science by advancing transparency, reproducibility, rigor, and ethics in research. We do this by generating evidence, doing meta research, by increasing access to open science education, doing seminars like this and other events, and by strengthening the scientific ecosystem through different initiatives. The BITS Open Research Seminar, ORS, is generally supported by the Templeton World Charity Foundation, and it's a new webinar series to promote and share knowledge about the use of tools and practices for transparency and reproducibility in social sciences. Today is our second of 4 scheduled events. Today we have the pleasure to count with several team members of the DIME team at the World Bank, who are going to be talking about the great work that they do about normalizing reproducibility and the experience of the World Bank group and DIME. They have been doing this for years. They're a great partner of BITS, and I'm very excited to see what news they have to share with us on this space. The next 2 sessions, one on November 17th, is going to be about hash linkages for administrative datasets with Carla Palos Castellanos from the California Policy Lab. And on December 6th, we're going to have how to evaluate journal implementation of open science standards, the trust process by Sean Grant from the University of Oregon. For more details on the research seminar, please visit our website and subscribe to our newsletter or follow us on social media to be up to date on the latest news on BITS and the research seminar. Thank you very much for everybody who submitted proposals. We received several very interesting proposals from researchers, practitioners, and students around the world. And we encourage those who weren't selected to apply for the second round that will take place in the winter and spring during 2023. Thank you to our speakers, to our staff who organized today's seminar, and to the Templeton Charity Foundation, and for those of you to attend to this event. We're grateful to be working with all of you. Now it is my pleasure to introduce the first speakers of today's session. Joining me today, it's Maria Jones, a survey specialist from the Impact Evaluation DIME unit at the World Bank. At DIME, she coordinates DIME Analytics and an initiative to increase and standardize quality across the DIME portfolio, and works on agricultural impact evaluations. Maria?
Great, thank you, Fernando, and thanks so much to BITS for organizing. We are really excited to join for the seminar today and to talk more about reproducibility practices within DIME. I'm going to share my screen here. Fernando, do you see that screen? Just to confirm? Great. Okay, so let me jump in. So first, a little bit of context. DIME is the Impact Evaluation Department in the World Bank. So what we do is to generate high quality and operationally relevant data and research to transform development policy, help reduce extreme poverty, and secure shared prosperity. So our portfolio, as you can see here, is global, which spans all 6 regions where the World Bank operates and covers diverse sectors from agriculture to transport, water and sanitation, entertainment, education, and many others. And DIME has grown really quickly. I joined in 2009, and over the past 13 years, we've gone from just a handful of staff to almost 300 staff globally, managing a $230 million program, working across 62 countries, and have quite now have quite a large research team. And as we have grown, we have thought a lot about how to maintain and ensure research quality as well as reproducibility and transparency and credibility. And so to that end, back in 2016, Dime invested in creating a centralized unit that was tasked with developing systems and building capacity to ensure that all of our research meets, kind of best practice standards, and that it is reproducible and transparent and credible. And that team is Dime Analytics, which is the team that I lead. And really our goal here is to take advantage of the concentration and scale of research at Dime to identify constraints and inefficiencies in the research production cycle and develop and iteratively test solutions. So we work continuously across the whole global portfolio to see, what are the problems teams are having, what kind of challenges are there, what workflows would make things more efficient or more reproducible, more transparent, and then how can we help to catalyze. Are there new tools needed in order to work more effectively? And how can we help catalyze the adoption of both existing tools and tools that we develop in order to have improved workflows and the most efficient and effective research possible? And we also focus a lot within analytics about ensuring the credibility of Dime research, so that what we do is really high quality and reproducible. And we monitor the compliance across all of our global teams. And probably the most important part of this for this audience, I think, is that we have a strong commitment to then making all of the resources and protocols and tools and processes that we develop public, both to benefit Dime, because we think that spirit of transparency actually is helpful for us because we get great critical feedback about how to improve our own processes, but also to make all of those resources and tools available to researchers across the global development research community, and especially in the institutions that don't necessarily have the capacity to do some of this internally and just don't have the scope and scale for it to make sense. So jumping into today's topic specifically, which is on reproducibility. So the first point here, I think, is why does reproducibility matter to Dime? Why is this something that we've really invested in over the past, let's say, about 5 years? And I think the fundamental point here is that we are in the business of trying to influence policy and trying to generate evidence that policymakers can use to make decisions about whether they should scale up certain programs and practices, scale them down, think about, in general, how they can more effectively help lift people out of poverty and ensure, shared prosperity. And so we think that it's really essential in that for policymakers and, other stakeholders to be able to understand what we're doing, scrutinize what we're doing, and recreate the results themselves. And so what this requires is having all of the data that we generate be publicly accessible, all of the analytical code that we write to analyze that data be both accessible, but also written clearly enough that it can be well understood by third parties. And that before we release our research results, that we validate that they all can be reproduced, that what we're doing, is consistent, and the research outputs reflect exactly the data and analytical code that is being published alongside them. And so over the past about 5 years, we've made a lot of investments across Dime to try to institutionalize reproducibility. And this is happening on a bunch of different fronts that I will touch on briefly, and then some of my colleagues will go into in more detail. But I think there's 6 here that I want to point out as kind of the areas of focus that we've had. The first is encouraging the use of GitHub for code development and trying to really catalyze adoption of GitHub across the team. The second, and these are kind of roughly in chronological order, the first push we made was to get our projects using GitHub, make code transparent and available, and encourage kind of more effective processes that way. Then second was this focus on computational reproducibility, ensuring that all of our publications meet that standard. And I'll talk more about that. Then the third was introducing a frequent peer review system for code to try and get more feedback earlier on in the process. Then, alongside all of these, developing lots of tools and trainings to think about how we can automate more some of these some pieces that will help to, again, just kind of make our default practices reproducible. And then developing a technical onboarding program for all of our research assistants so that from the beginning, they understand what the expectations are around reproducible research, and they also have the tools that they need to implement reproducible workflows from the outset. And then finally, we've run a number of what we call boot camps to catalyze real-time adoption across our portfolio. So to say, okay, one thing is to have new projects that get started, follow these workflows, but we actually want to make sure that this is happening on all of our global portfolio, even for projects that have been ongoing for some time. And so thinking about how we can, kind of do real-time adoption. So I'll touch a little bit more on these. The first point on GitHub is, again, this was our first push, was to say, okay, we think a basic premise for reproducible research is making sure that code is done transparently and in a way that's easy to then publish and share with others. And so we started to push adoption of GitHub with a bootcamp in 2016, showing everyone how to do it, creating repos in real time. And we've gone from having one DIME project using GitHub in 2016 to more than 150 now in 2022. So quite broad adoption across the portfolio. And we think this is kind of a fundamental starting point because it really facilitates everything else that we do, especially the code review processes. And here, and you'll hear me emphasize this as we talk about each of these areas, we again have made all of our materials accessible. So all the GitHub trainings that we developed and ways of structuring teams in GitHub to facilitate the research practices that we have in a public repository so that others can use those trainings or team structures and set up if they want to try and push that in a similar way in their institutions. So second point is on computational reproducibility checks. This I will only touch on very briefly because Luis Eduardo will speak next in a lot more detail about why we do this and what we've learned. But the basics are that back in 2018, we started to require that all DIME research outputs before they go to working paper stage have to pass a computational reproducibility check. So that means that the code and data provided have to generate all the same outputs, the same analytical outputs that are included in the paper. So there is a package that can be then included with papers as they are published and submitted to journals. So we've now done more than 60 checks and I think learned a lot over the process that Luis will talk more about. But one thing I wanted to emphasize here that I think is useful is that, journals are increasingly doing some of these checks and requiring them. I think it's less common for research institutions to do them in-house. But our experience has actually been that there's a lot of benefits of doing it in-house. First, just because we improve the quality of the papers that we're putting out. We catch a lot of mistakes in-house, and that's useful and important to before these go out, even at a working paper stage. But I think probably more importantly is that we are able to learn from those reproducibility checks at a portfolio level and think, what are the common issues and mistakes that we see? What are the common problems? And then what do we need in order to improve? Are there, is it just a matter of new trainings for, for any of the team members, or is it actually that some different tools could help to make things more efficient and encourage coding in a more automated or reproducible way. And so that is actually a really key part to how my team prioritizes our own work program and agenda, is thinking, okay, do you know that these are common issues the team is facing? These are ways our research is failing reproducibility checks. What do we need to do to make that better going forward? And then we design our own sort of tool development and training development accordingly. So after a couple of years of doing reproducibility checks pre-publication, we thought, really, we should be doing this earlier on in the process, that it's one thing to do it pre-publication and it's important, but it's often not really at an actionable stage in the project. It's not that you're going to want to go back and rewrite all of the code when you're just getting ready to publish a paper. So that is, we thought, okay, how can we come up with systems and structures that would encourage real-time, adoption of these improved practices and encourage people much earlier in the research stage to both to adopt improved practices, but also that there's some openness and accountability as to whether that's happening. And so what we did was to create this peer code review system where on a quarterly basis, we do a structured exchange of code amongst all of our research assistants and anyone else on the team who's written code and wants to participate. Where we have, kind of a structured review process with checklists, things to look at and give feedback on. And so there's a lot of opportunity for direct feedback on the code, which is useful. But it also gives us a good sense, again, kind of at a portfolio level of like, what common practices are being adopted, what are not being adopted, where do we need to push further? And I think probably most importantly is it really helps to foster this culture of open code and for people to be comfortable sharing their code, even when it's works in progress and getting feedback from each other. And it allows our research assistants and all other staff to start learning from each other as well. Just reading other people's code is often really informative, and this provides kind of a structured and kind of mandatory reason for doing that. And again, it informs from Dime Analytics side, it informs our own kind of curriculum and tool development. So I want to talk a little bit more about this process because I think it's more unusual than some of the other practices that we do. So what our peer reviewers assess is there's 4 kind of main areas. The first is transferability. How easy is it for someone else to work on this code? This is something that's really important within Dime because we're typically working in these large global research teams. And so we want to be able to transfer code. Then maintainability, how easy is it for someone to modify the code, reproducibility and readability. Then at the end, there's a structured kind of standardized diagnostic that projects get about, what standards their code meet and which particular practices they have adopted and where is there areas for improvement. Okay, and then in general, as I said, Dime Analytics tries to develop a lot of open source and open access tools and trainings to improve reproducibility across the research production lifecycle. A couple of those that I'll mention here. The first is a development research and practice handbook that we put out last year, which is kind of a single narrative of the best practices that we adhere to across the research life cycle. That's freely available. I've linked it here. The second is a whole suite of Stata tools to improve reproducibility, readability, and transferability of code. And Ben Daniels will talk a lot more about that in our third session here in this panel. And then finally, we also have a continuing education seminar series that we do, which is about bi-monthly technical sessions on particular tools or practices that we want to improve across our portfolio. And those again are open. All of the materials are posted to the Open Science Framework and accessible to everyone. And finally, the last is again this just standardized training program for research assistants. So trying to get all of our new RAs on board when they come on board, get them aware of the expectations for reproducible research, why it's important, and give them access to all of the tools and platforms that they'll need in order to meet those standards. So I will just wrap up by, I think emphasizing that there are clearly benefits to Dime to doing this, and we have, I think, our own research quality is unambiguously improved by these kind of institutional commitments that we've made to reproducibility. But we also recognize that not all institutions are going to have the capacity to do this internally, and so we have made all of our resources around reproducibility, and I put reproducibility in brackets here because it's in practice just all of Dime Analytics resources are public goods, but specifically focusing on reproducibility here. The whole system and process that we've developed for our computational reproducibility checks and also the peer review process are available through our GitHub repo. So somebody else could say, okay, I want to do this. I'm just going to take this process and transplant it into another institution. And we would say that that's fantastic. That's exactly what we want. We also want to know, did you improve it? How can we improve it? And just fostering that culture of transparency. But also all of this data tools that we have put together are developed on GitHub and explained on the DIME wiki, published on the SSC. So again, everything is very accessible and citable and adoptable. And finally, all of our training materials, as I mentioned, are shared on the Open Science Framework. So I think I went a little bit over my time, but hopefully not too much here. And with that as an overview, I want to hand it over to Luis Eduardo from the DIME Analytics team to talk in quite a bit more detail about the computational reproducibility checks that we do, what that process looks like, and what we have learned. So Luis, over to you.
Thank you, Maria. I think you need to stop sharing your screen so I can share mine also. Okay, there we go. Okay, perfect. I'm assuming you can see my screen. Let me know if you don't. And yeah, so first of all, I am Luis Eduardo San Martin. I am a data coordinator in DIME Analytics. And I am part of the team that does the actual reproducibility checks of our work. I am going to be talking about how we do this. And with that, I mean, what is the actual process of conducting reproducibility checks so that you can also learn how to implement this in your own work, for example, of how to check this in a colleague's work. And I will also be giving you some recommended practices so you can ensure that your entire data workflow is reproducible in all stages. Okay. First of all, some background. As Maria explained, this is journal publication stage that all of the projects and all of the papers that come out from our department go through. All of them are required to go through a reproducibility check that our team conducts. This was institutionalized in 2018, and we've reviewed 62 papers until now. Many of these reviews required like several rounds of reviews. I think in average, one paper requires 2 rounds because they usually don't pass the first, they pass the second, and there are some that are only reproducible in a 3rd or 4th or even more round of reviews. And in general, in the last 2 years, the languages that we've had to review, because this is the code that the projects in practice use, are mostly Stata. Stata is the great majority in these projects. And like a 5th of them use R, and then a 10th of them use Python. You will notice that these percentages don't add up to 100%. The reason is because there are projects that use more than one software or language. And well, in general, this is how we do it. We receive the code and data in a self-contained folder that we call a reproducibility package. With self-contained, what I mean is that all you need to run the code is in the folder. All the data and all the code that is going to reproduce all the tables and all the figures that are shown in a paper. What we do is we run this between 3 and 5 times. In most cases, it's 3. In some cases, we take the extra effort of doing it 5 times. We compare that the outputs are equal across each run. That's that the outputs are stable. And provided that they are stable, what we do is we compare them with what the paper is showing. Because part of the review is that we also need to receive a draft of the working paper to compare the code results with the exhibits of the paper. In practice, like 1/3 of the projects pass in the first run. Then 22% of them require minor changes. What we call minor changes are changes that we as reviewers can detect and correct. They are usually things like typos. Maybe it's something in a file path that is not correct, but we can detect where the error is and we can manually correct it very quickly. Or maybe a package that is not installed. Those things that are relatively quickly to correct. Significant changes are changes that require us to go back to the team and tell them this is not running. Apparently the reason is X, so you need to address this and then get back to us so we can finish the review. And this is what we review in our checks. First of all, that the code runs in a new computer. I need to clarify that the team who is reviewing the code is not involved in the research or in the projects at all. So at most, what we do is we read the abstract of the paper just to have an idea of what this is about. We read the master do file, and that's it. We are not familiarized with the project. We are not familiarized with the development of the code. And we also run it in an entirely new computer. So that's our first assess, that the code works. Then we check that the outputs are stable, meaning that they are consistent across the 3 or 5 runs that we implement. And then, provided that the first 2 are true, we also check, this is usually a manual check, that the outputs that we have generated with the code are exactly what the paper is showing, also for all of the tables and all of the figures that the paper shows. That includes appendix, an online appendix, everything. As a result, we give back to the team these review outputs. The one in the left is a standardized checklist that basically is a very quick summary of first, the code runs, and second, the master script, the code in general is recreating the outputs as they are shown in the paper. Then we also have a few checks that are recommended practices that make our life as reviewers easy, but they are not, it's not mandatory for the teams to comply with the recommended practices. The required practices, they are mandatory. And this is just that first that the code runs, and second, that the outputs reproduce as they show in the paper. Then what you can see in the right is our second output of the reviews, which is a detailed document that has coding suggestions for increasing code legibility, code efficiency, and it also contains a detailed list of all the outputs that we found in the paper and what's their reproducibility status. So if an output reproduced, what we're going to note here is that it just reproduced. If it reproduced, but it's obvious that there are some, for example, style changes between what the code is producing and what the paper is showing, we also know that, but that in general is in line. That doesn't break our reproducibility standards. If it's only like style, differences. But if there is something like the code is not stable, or the results do not, a table does not reproduce as shown in the paper, or it reproduces, but the paper shows that there are additional rows that seem to be manually added. Those things we mark as not in compliance with our reproducibility standards. And the rest of these slides, in the rest of these slides, I am going to show you how you can implement this by yourselves. And in general, this is following these three like general guidelines. First of all, keep your code simple and well organized. For example, include comments in your code, keep it modular. With modular, I mean, try to have one do file for each exhibit that you are including in your paper. Like, for example, if you have table 1, create a do file that is table1.do. If you're using Stata, if you're using R, create a script that is table1.r. And do this for every one of your exhibits such that your entire result is modular. This is going to keep your code simple and well organized. Our second general guideline is streamline everything that you can. Don't rely ever on a copy-paste workflow for this, and use LaTeX, for example. If you can use something else like that is even more streamlined, like for example, a Markdown implementation in a software like R Markdown, that's even better. I'm going to talk about that in a bit. And also automate the reproducibility checks as much as possible. There is a part of the reproducibility checks that we do manually, and I'm going to tell you what that is. But in general, we try to automate the checks so that they are not prone to human error, and that's what we try to keep in our workflow for reproducibility checks. So first of all, how do you run code in a new computer? This might seem a little bit obvious. But there are good practices for this. First of all, to check that it runs in a new computer, you should create a self-contained reproducibility package. This is just a folder that has all your scripts, all your data, and also has the subfolders that follow the creation of your outputs. It's also a good practice to include a master script. If you're using Stata, this will be a master do file that are going to run all the necessary scripts that create all the outputs of your code. And also a README file that will have some explanation of what the code is doing and what each script is doing. Yeah, so use a master script and make sure that your master script is complete, meaning that if you run the master script, everything is going to be created. With everything, I mean everything that you're showing in your output. A very simple version of a README is a recommended practice for this, looks like this. That is very welcome, but at the very least, you should have a README as a recommended practice that is explaining this part. Then in your master script, a recommended practice is that you set all critical software configuration, like for example, versioning, matrix size, if you're using past versions of Stata. And this should be included in the beginning of the master do file. Then in the master do file, you should also install all external commands that your code is doing, because remember, if you're running this in a new computer, chances are that that computer is not going to have all the external packages that you are using. The same applies for R, for example. And you should make sure that your master do file is handling all of this. And then, of course, define folder paths and try to keep this as simple as possible. You will see in line 24 here, this is defining a global master and ideally this should be the only time that all the code and all the do files and all the scripts are changing and setting the master script. Sorry, the master path. Everything after this should be relative to the master path so that for an external reviewer is as streamlined and as simple as it can be. Okay. Then for coding stable outputs, the way you check this is it's very basic, really. You just run your code a number of times and you check that all the outputs are consistent. You can do this manually. It will be a bit tedious, I can say that for you. But there is also an automation tip, and this is actually how we implement it in our team. First of all, make sure that all your outputs, your code outputs, that is, are text-based format, like for example, that you are creating LaTeX tables and not Excel tables. If you're using figures, try to use vector formats like SVG or EPS. You can also use PNG. I would say that's acceptable, and that's in our practices, it's acceptable for sure. And the reason for that is that a cool tip for automating this part is that you can use Git, and you can use, for example, GitHub Desktop for checking checking if the outputs are stable. And this screenshot is an example for this. You can see I am assuming you can see my cursor, but in this second column of the screenshot here, this is a list of all the outputs. All of these are text-based and PNG files that between the first and the second run changed, okay? And if you select one of them, you can even see in a very granular way in which line the changes are. So this is, for example, telling me that line 4 in the first run was as it is highlighted in red, and now line 4 is as it is highlighted in green, okay? This is very, very useful because, for example, in our reports, when this happens, what we note is, first of all, that this is happening, and second, we try to look at the code and check on what are the possible reasons why this might be happening, and we communicate this to the teams so they can correct this in their code. So a quick automation tip is use Git and use GitHub Desktop, which facilitates the work greatly. Then recommended practices. This is for Stata because most of the code we review is in Stata, but in general, these principles also apply for R or other software. First of all, make sure that you are versioning your code, because in many programming languages and many statistical software, the pool of pseudo-random numbers that are used for randomization, they change between versions. So versioning your code is a way to make sure that no matter which version a reviewer is using, the pool of random numbers is going to have the same order, okay? Other than that, make sure to set a seed. This is very, very this is critical for getting reproducible results if you are using random variables. It's a bad practice to use a seed that is, for example, today's date or your birthday date or the number 1, 2, 3, 4, 5. What you should do is go to a source of a truly random number, like for example, random.org, and extract a number from there and use that in your code. But that's not the only thing you need to do. You also need to make sure that the sorting is unique. So before generating a random number, sort your variables in a unique way, unique meaning that every time you run the code again, all the sorting are going to be consistent and always the same. And only after you have done all of this, versioning, setting the seed, and also making sure that you're sorting uniquely, only after that generate your random variable or implement your random process. And lastly, yeah, I'm still good with time. Yeah, I want to talk about how we check the reproducibility. If you were expecting a trick to automate this part, I'm afraid that we don't have one until now, at least. In general, what we do is we manually go through every code output and we manually corroborate that this is the same as what the paper is showing, as you can see, which is what I'm trying to show in this example. But there are definitely good practices that can help you increase the chances that this is happening in your research results. First of all, organize all your outputs in a single folder. Like remember, in your self-contained reproducibility package, you will have an outputs folder, and inside that outputs folder, try to divide everything between figures and tables. If you also have something like results in the main section of the paper, you can also use those divisions and versus, well, a folder like that, and also including a folder that goes for an appendix and for an online appendix, and between each of these subfolders, you have figures and tables, and that is a good practice for division. And also, of course, use file names that easily relate to paper exhibits so that any reviewer will know, okay, that file that is reproducing in the paper table 1 comes from table1.tech. Okay, we have seen some projects where teams are using things like balance table _ final _ for seminar, things like that. This is very like, well, this is an obstacle for any external reviewer of your code. So use file names that are going to be easily relatable between the paper and the outputs. Then, as I already said, don't copy paste. Every output that you produce should be exported on a file. If you're doing something like, for example, you're creating a map, let's say in QGIS or ArcGIS, keep in mind that if you're creating this map manually, that is very likely to also be done, to also be possible to be done using R, for example. R has a lot of very great packages for creating maps and for geographic data analysis in general. So don't copy paste. Our recommendation is don't ever copy paste. Export every output to a file and use LaTeX or another text compiler in general to read and to import these files that you're creating with your code. Having said that, there's an even better practice, which is using Markdown implementations. What I like about this is that if you are using, for example, a master do file to generate all your code outputs and then LaTeX to produce your paper, every time you update your code, you're also going to have to run or to render your paper again. You might remember this all the times, but chances are this is going to fail somehow. And in practice, because we do this, we've done this for 60+ projects, this happens a lot. Like teams forget that they updated the code and then they don't render the paper again. And it happens that we are reviewing mismatched versions between the code and the paper. So if you want to make sure that every time you're producing code results, you're also producing and updating your paper, you can use a Markdown implementation. Our Markdown, for example, is a fantastic Markdown implementation, and it allows you to customize, like you can do anything that you can do in LaTeX in general, you can also do in our Markdown, and it's great. There is also Markman implementation in Stata, which is Markstat, which pretty much does the work. The only issue that I have with it is that it doesn't allow you to customize your paper part very much. But in general, if what you're doing is, let's say, a report or a draft, it's a good option. And with that, that's everything I have. Now I am going to open it a few minutes for Q&A, and then we'll go with Ben, who is going to talk about what are the tools that our team has developed based on the learnings that we have for having reviewed these 60+ projects in the last 4 years. Thank you very much.
Luis, there was a question in the chat that I think you can answer well, given your experience reviewing these. So it was that wouldn't a reproducibility check be challenging when you have either a lot of software dependencies or very large data sets? And if you can talk a little bit about the protocols that we have around those.
Yeah. First of all, I would say that that's definitely true. In our experience, we only have received packages that run code in Stata, R, or in Python. We are a team that has the capacity to run those software. So in general, we haven't had a challenge with that. There is a challenge in the sense that if you are using different software of different languages, you're gonna maybe have to use one master do file for each, right? What you can do is in your README, you can specify what is the order in which each master do file of each software needs to be run. Or you can also do, there are, for example, implementations of running code of Stata in R or running R code in Stata. And you can use that and implement that in a single master do file, either from Stata or from R, to streamline all of the results that you're producing in different codes. And also, well, if with software dependencies, what you are referring to is external packages. Like, for example, if you have to install a lot of external packages to run a code in R and also or a code in Stata or a code in Python, I would say that is very much, it will be complicated if you're using a lot of external packages, but it's doable. And if you keep a good code organization, it's possible to organize all of that in using your master do file and using a good reproducibility package. So it's challenging for sure, but it's doable. And in general, we try to emphasize these points in the trainings that we do, especially with people who is joining the team when they just join the team, so that they can keep this in mind and streamline all of the software dependencies in the code. And for larger sized data sets, yeah, in our experience, I think that the code that we have reviewed that I remember that took the most time and it ran, 2 days the first time, then 2 days the second time, and 2 days the third time. So it took like, in general, the review took like 10 days, I think, which is more than what it usually takes to our team, but it was doable also. Yeah, so that's how we manage it. And I would see that not all the teams have the chance to use an external or a virtual machine to do their reproducibility checks. And yeah, in those cases, maybe you can achieve a second best, which would be, review the code manually and make sure that all the practices that we are listing here are being complied in your code. That would be a second best, probably, if you don't have the chance to run a code that is very large in your own computer. Which aspect of this process you have gotten the most food dragging from your researchers?
I can maybe jump in there. And Luisa, then, and feel free to add too. I think that, I would say overall, I think it's been really important to have a bit of a mandate from the top on all of this, to have, kind of our directors say, this is something that we are going to do at a department level. And then, our team is tasked with actually making that possible. But I do think that there's bit of a need for catalysts, because some of these sort of practices do involve researchers changing the way that they do things, or adopting new tools or new platforms a bit. And it's I do think that can be challenging. We have tried to make it as simple as possible, to basically wherever we see bottlenecks, to try and make tools, right, that will make this easier and make a default that's easier. But probably I would say areas where I think it's fairly easy to get adoption. I'm just sort of jumping in here, but I think where like we've had really good adoption of GitHub. I think quite good adoption of using master scripts to organize reproducibility packages. Then some of this, like, for example, what's going on in the chat right now of talking about how do you really manage, Ado files and data, or how do you, there's some of these kind of, as you get more into the details of problems that are, I think, harder to address, but also because people just are not as aware. So, Luis, do you have any thoughts to add?
Yeah, specifically to R Markdown. Well, first I need to clarify, R Markdown is something that we've been pushing in our team, but we haven't been really very successful. Like we haven't had a review that uses only R Markdown. That is something I would like, because it would make our lives as reviewers easier, but it hasn't happened. Having said that, I do agree that identifying errors and bugs, for example, if the code breaks, it would be more difficult to identify where it is breaking if we were using R Markdown. But still, I think it's possible, and our experience, as code reviewers, I think we would probably would take more time, but we would be able to identify where it is breaking. And yeah, well, and also I need to say, usually the reproducibility packages that we review have, that they are sourcing embeddedly many different scripts. And I think when you're sourcing scripts, it's also it might be quite difficult to identify exactly in which line and in which script an error is coming from. Yeah, but it will take you more time, but you can do it anyways. And I would say something that we also ask teams to do. I am sure not all of them do this, but we usually ask them to first try to run themselves the code at least once in a new computer to see if it runs before giving the review to us. So if you are familiar with the code and you run it in a new computer, even if you're using Markdown, I think you might be able to identify where the error is coming from. And yeah, so that would be my take on that. Yeah, but definitely it would be interesting that they start submitting projects in our Markdown to see if what you point out would actually happen. Like if it's like more taxing for us to identify where the error is coming from versus using a script implementation instead of our Markdown.
There are a couple more questions in the chat, but I would suggest we do hand it over to Ben now, just because I don't want to miss any of the content, and we'll try and address those questions in the chat, and then hopefully we'll also have some time at the end of the session. We'll keep these questions for then, but we will certainly answer in the chat if we can't answer live. But Ben, for now, why don't we hand it to you?
Great, thanks very much. I just want to start by saying that's really a great summary of what we do. And one thing that I think always surprises people when we give these kinds of talks is kind of how low level and low tech the most important elements of this process are. And we'll hear a lot at some of the you see the cutting edge conferences about reproducibility, a lot of the work from Bits as well, which is very high tech, a lot of dashboards and R coding and package management and containerization, and it's super cool and really wonderful stuff to see on the cutting edge of what can be done with big processes. But in the main, our work at Dime Analytics, because we have so many projects, most of the time loss in our process comes from very small, very routine things that repeat over and over at a large scale across a large number of teams, some of who are doing very cutting edge stuff, but all of who have to do the basic stuff in every project. And as you undoubtedly noticed from Luis's talk here, while it's quite easy to code hacks around it from the project side, to code well or code badly from the project side, evaluating it once it hits our desks in terms of doing a thorough analysis of the reproducibility of the quality of the code. And I think that is a quick one that I can respond to here is that, yeah, we are centrally reviewing these projects. When by we, I mean Luis primarily at this stage. And that is a lot of work. It's not a task that is extremely easy to automate. It involves potentially manually reading a lot of low-level code to find potential issues and to look for mismatches in outputs. And so the work that we've done in terms of developing tools for the team, which I'm about to launch into, has in large part been about making those basic tasks easier to write and to review. So in addition to our book, sorry, I almost called it by the original draft title, Development Research and Practice, the DIME Analytics Data Handbook, which is centered on, is available for free online. We have a number of tools, trainings, resources, some that are publicly available, some that are done inside our team to basically encourage standardized and reproducible code structures from the day that people are onboarded into DIME teams. We have a very clear research workflow in terms of what should be done and what should be produced at each stage, and in what way it should be done and produced, how it should be stored, what outputs will look like. This is built from our side, from a large lab side, because we have research assistants and staff working on multiple projects at the same time, working across multiple teams at the same time, turning over staff across the life cycle of a project. I mean, this is it is a organized corporate type of endeavor to run this place, and that's a big change from the master and student type of PhD ivory tower research organization of, I would say, only about 10-15 years ago. And I think this is more and more at least coming to dominate in our field. What we've done as we're developing these processes is make sure that they're also suited for individuals, in the sense that the efficiency gains don't come from the scale of what DIME is working at. Our view is that by working towards reproducibility from the beginning of a project, the project is actually easier if things are done the right way. So all of the costs, people think sometimes, oh, it's a chore, there's all this stuff I have to do, this big task list of things that are really only for the point of someone else's ease of reproducibility. We don't write our code that way. We don't do our lessons that way. We say, if you're doing it this way, the only cost should be in learning the processes, and everything from there on out should be paying back to you in terms of time and ease, so that the onboarding process, the time spent in onboarding and training for new hires at DIME, is paid back to them in terms of ease of work, is paid back to their TTLs and supervisors in terms of additional productivity, and everybody comes out of it happy. And the gains can be used to do things like pay mine and Maria's and Luis's salary to do things that are useful to the team, like develop additional processes, do reproducibility checks, certify, that papers are coming out at high quality, and take on training and ad hoc support for these teams without having to do it on a budget by budget ad hoc basis. So it's, using some of that surplus to fund the public goods. And that has been the model that works, as Maria said, with the support of the leadership primarily is absolutely essential to this working. But because we're doing it anyway, we're publishing it so that anyone can use it, and even it pays back on an individual level if you take a moment to learn the system that we put together, and it does really go from start to finish. So some of the tools that have been out there for a while, here is IE Toolkit, which is one that I think is reasonably well known and has been out in the wild for like 7-ish years, and it was developed from the very beginning to automate a lot of the processes and structures that are used very frequently in our work, from the structure of folders that are used across a project, so that every project at Dime more or less has the same folder structure for code and data across its entire lifecycle, no matter how many rounds of data collection or analytical processing that might be. You're always going to be looking at essentially the same structure, very easy to transfer from project to project. Not listed here, but we have things like balance tables, difference in difference tables, and other types of really common analyses that reduce what used to be, a manual ad hoc process of, okay, I need to run all these regressions. Here are the checks I need to do. I need to aggregate these results. I need to make a table. I need to write it out. Everyone who figures this out from the ground up is going to do it in a different way. But when you use something like IE-BAL-TAB or IE-DD-TAB to create these super common tables, you're going to do it in less code with less room for error. It's going to be easier for other people to read and review whether it's done correctly. And the outputs are going to come in a consistent format where we can say, okay, we know that this is a fundamental part of the work. Everyone's going to be doing this. We know that this is going to be done right and doesn't require Luis to spend one day reviewing, oh, you've missed collecting the P values at this, or you haven't adjusted the t-tests for your multiply hypothesis like you said you would, or something like that, whatever is built into these tests. So IE Toolkit handles that from the analytical code side of things. As the past few years have gone on, of course, people have become much more interested, or at least substantially as interested in the quality of data processing and the reproducibility of data processing. And that was one of the big spurs to us to putting this together in the full book format, is that now the mindset covers the entire research lifecycle. Further, it led us to develop IE FieldKit, which is about the collection of the process of receiving data. Obviously, our stuff is primarily around fieldwork, but this can also easily handle stuff like secondary data received from partners. It's about the reproducible receipt and processing of data. And in the same way as IE Toolkit is about reducing the amount of manual, bug-prone code that individuals have to write, IE FieldKit does the same thing for data intake. It allows you to quickly make corrections to data, remove duplicates from data, change metadata such as labeling, recoding, value labeling, harmonizing data sets, and creating code books, which are a pain to build from the ground up. But when they're reduced to just 1 or 2 lines of code with substantial self-documenting metadata as in IE FieldKit, it becomes quite easy for us to check. We can build into all these tools automatic error checking so that we know that simple errors such as ordering of renaming and relabeling and recoding is not being messed up, and we don't have to spend time reading thousands of lines of very low level code to make sure it's being done right. The program will simply stop and say, you've done this wrong, before it hits our desks. So again, saving everyone time, increasing the quality of the documentation. And now I'm not going into these in detail, but please check out, please check out the book. We have these on GitHub, and IE FieldKit is in Static Journal, and there's lots of blogging on development impact about all these tools. The result is that this here, which probably would have taken thousands of lines, depending on the size of the data set previously, now fits in 15 lines and cleans up everything, and we don't have to read it or make sure that it's doing the same thing each time. And it's much, much easier for someone who's writing the code to do it, know they're doing it right, and participate in things like the peer code review before things are handed up the chain to publication and errors are found much later in the process where the downstream consequences are serious. These things can be caught much earlier on, and everyone can go home at a reasonable hour and sleep at night. In addition to that, we also train and have style guiding, which is one of the first times that that's been released in a static context. It is opinionated. It is the way that we do things and we want people to do things. And the reason that is because it makes it easier for us to share code among ourselves and to review it. You don't have to agree with our opinions, but you do have to respect them, and we would prefer if you followed them. So simple things like what Stata has built-in commands that we don't like to use. Stata has abbreviations that we don't like to use, in part because it works well with code that we have, but mainly so that everyone's on the same page. If a different group takes a different style guide and a different consensus around what they're going to do, fine, that doesn't bother me. But if it's going to end up on my desk or on Luis's desk, It's really helpful when things are in a format that we anticipate, and the same for peer code reviews as things are being passed around the office. We don't want people spending their time getting creative in the sense that this is a computer. Computers should be doing the boring work, and we have more time for important thinking tasks like actually doing research, development, of handling data, of doing modeling, of doing statistical inference, of running our projects, the things that computers are quite bad at. To support this styling guide, a number of members of the team, including Luis Seguena specifically, have developed a linting command in Stata, which just reads your do file and tells you whether we'd like it or not. It involves basic enforcement of things such as making sure that code lines aren't too long, that for loops are using descriptive names, that indentation is generally in the right place, that we're not using implicit logic, and things like this that are easy errors to make, and that, again, may work functionally in Stata, but could induce errors that are hard to catch, that would require us to read the do file more closely if this isn't done, and actually to parse it, as in, for example, if you're using the dot operator where you should be using the missing function, that means that we actually need to read that and find it, rather than having the lint command automatically flag, hey, this can induce errors, and either you shouldn't be doing that, or you should check it before it gets to us, or we can very quickly catch, oh, there are potentially error-ridden practices in this code and kick it back. So that's the basic level stuff. Now I have some exciting stuff for everyone, which I think was advertised on Twitter, and I know got a little bit of passing around, is that we're trying to put ourselves out of a job constantly, but we seem utterly unable to do it. We've now come up with a way in beta to do a substantial amount of the checking of reproducibility errors in Stata code automatically. This is in our internal beta. We're going to be hopefully releasing it soon-ish. It's got bugs. Nothing's perfect, especially in Stata. When things hit the real world, they tend to break, but we're intent on making it work. If you see this right here is just example bad code that I've written to show what bad code looks like and why it's hard to catch. It is not easy to see necessarily that the sort seed is being used unstably on line 19. It is not easy to see that it's being used unstably on line 27. It's not easy to see that the seed is being used unstably on line 23 before being set on line 25. These are things that are hard to catch. As Luis said, we can check outputs on a run-by-run basis using version control, but it's difficult to then trace backwards to where in the code those instabilities are coming from. So we decided to automate that process because it turns out to be something you can do, although in a limited sense, and I'm happy to discuss some of the technical limitations on that outside of this forum with people who are super interested, because we have more things that we've tried to solve and not been able to do. This is a command called ie_do_rep. It does the beautiful thing of running the Stata code twice while you walk away and make coffee. It then tells you very cleanly here where errors are coming from. Because it can run the code twice and track the underlying state of Stata's memory at all points, it can tell you, did the data have the exact same form at the same point across both runs? Was the seed at the same point at every point across both runs? Was the sorting order the same at every point across both runs? And in our development process, we pretty much agree that that rules out about 99% of error cases that are hard for us to find. And while we used to spend a lot of time scanning through to see, there must be a seed changing somewhere in here, where's the random process I'm not catching? Now it's just done for us. This can also be done with a verbose setting that'll check anytime these things are done, even if they don't result in a mismatching state. So that can be done for a replicator's ease, or just as a diagnostic to see how clunky code is running in terms of reloading or changing data very frequently. And finally, as you can see on the line 31 of this code, it is detecting that the instability is resulting from a do or run command and flagging out a do file. So it's appropriate for use on master do files or run files such that we can analyze an entire project in just one go of IE do rep. Now, if something is happening in a sub do file, we have a limited way of accessing that. It has to actually work stably. What we can do with that and have done is implemented recursive checking. So if the recursion option is on and errors are resulting from a sub do file, which is detected by flagging do or run commands, we then run that separately. So again, this does depend on files being written in a what we think of as a correct way, that they are able to be executed modularly, that there isn't deep dependency on the order and way in which code is run in it that is itself unstable. But that works for any number of sub levels, and it will continue recursing the code until the errors in the fundamental errors are found to the extent they can be. So we can now scan very quickly and remove a lot of what was the manual labor of finding the source of errors if this stuff is built up from the ground up. That is, people are following basic good coding hygiene. People are following basic good project structures that we've built out over time and trained the team on. And people are using good organization of scripts so that these things can actually be executed. And this can be done by the user as well before sending stuff in and asking for help. Again, it can save a lot of time to do things this way. Again, there are bugs, there are some memory issues and data that make this difficult, but as long as coding is done well and people aren't trying to do insanely fancy things with juggling memory, this works, and it works for most of our problems in most of our code. So I'm going to leave the tools section there and stop sharing the screen. I think that's about the right timing, possibly a little short, but that's always good. So I will leave that. Are we doing another Q&A now, or would you like to move through and take one at the end, Maria?
I think let's go ahead onto Aaron's and then open it for Q&A for both or general Q&A at the end. So Erin Kelly is one of the economists in Dime, and we wanted to invite her to talk about this process from researcher perspective and how it's useful for the publication process. So Erin, let me hand it over to you.
Awesome. And can you see my screen? Perfect.
Yes.
Okay. Sorry, I went ahead. Thanks very much for having us speak today. I think the purpose of my part of the presentation really is to outline how I have benefited as a researcher in doing this, and the different ways in which I've benefited, and which I think others can benefit from in the same way. So the first thing that I want to emphasize is there is a broad application of these reproducibility checks. So I've used it in a number of different ways, and a priori I wasn't clear whether it could just be used for my small admin or my small RCT data, or whether it could be used for other purposes. And what I found out is it can be used in a variety. So the first time I used it was actually for a JD pre-result submission. So we had the baseline data, and it was very helpful to put together sort of the balance table, some of the code, which ended up being very useful for Endline because all the variable names and things like that were the same. And I'll talk a little bit more about that. The second one is I do a lot of RCTs, so it's been extremely helpful for all of my work in that domain. And then lastly, and this has been one of the kind of the newest applications that we've or that I've had the benefit of seeing is running a reproducibility check on administrative data that's protected by an NDA. So I'll talk a little bit more about all these applications in the end. But what I really want to emphasize is, we've had presentations today that go through all of the details of these reproducibility checks. And so I think you can sort of see it for yourself. And when I was preparing this presentation, I had to think, okay, well, what do I really want to emphasize as being the benefits that I took away? And the first one is writing clear and efficient code. And I think that's something that was emphasized by the other speakers, is to the extent that you have clear and efficient code to start with, the reproducibility check is not so onerous of a process. And I think through this through these processes. I've gone through it a couple of times, as Luis Eduardo was saying. I failed it a couple of times, and so through the process of learning, my code has just become much clearer and much more efficient. And I'll show you some examples of that. The second main benefit has been confirming the validity of your results before sending the paper to a journal. And I think there's nothing worse than sending the paper, having 3 reviewers and the editor look at it, and then realizing one of your tables has changed. It's mortifying. And so it creates a lot more work as well. So being able to confirm that what you're preparing and submitting to papers is reproducible and valid is extremely useful. And then lastly, it speeds up the publication process. So we recently went through this with a paper that looked at the psychosocial benefits of work among Rohingya refugees. And it's not an exaggeration to say that the data replication process took under a week. And that's, not, as far as I've heard from my peers, that's fairly quick, just because everything was ready to go. The only feedback that we got was to make our README package in line with the specifics of that particular journal. Okay, so in terms of the first benefit, writing clear and efficient code, I think this was touched upon by the other panelists, but I want to emphasize it from my perspective as well. The one thing that I've really learned from all of this is the benefit of master scripts. And so this may be obvious to everybody here, but if you have a master script with clearly designated clean build and analysis files, it just makes it easier for you to find things. But then also, I don't know if anybody has tried to replicate a paper. If you've done a little bit of, gone on to paper, if you've done an assignment in grad school, for example, there's nothing worse than opening somebody's code and just not being able to make heads or tail of it. So having these master scripts with clearly designated subfiles for different purposes, and then also making the code easy to follow, the second bullet point. So labels, labels, labels. You can't have too many labels telling your user what you're doing. You just can't. Even for my own code, when I go back a year later, I kick myself when I don't have that. And that's been something through the reproducibility checks that has been kind of hammered into me. The third point is one that came up a couple times in my work as well, is avoiding producing tables and figures with manually hard coded values. So this was sort of sloppy coding, right? Like we didn't really figure out how to make the stout or stab command work perfectly. And so we just ran some regressions, pulled the coefficients and put them in, and it's tempting to do that. But again, that was pointed out as it came through in the reproducibility checks again, that we shouldn't be doing this, and we knew we shouldn't. And so it was helpful to just have that reiterated. And then lastly, something that I think we all suffer from a little bit, and maybe is a little bit less now with pre-registration, but typically you often produce sometimes more tables and figures than you eventually put in the paper. Some move to the appendix, and some you might not even have in the appendix, and you can justify why. But it's helpful through this process. I've learned, how to be very clear about only having the relevant tables, because there's nothing more confusing for anybody looking back at it to have your code say you produce a table in the paper not saying you're doing that. So I will go over this relatively quickly because I think the other panelists have looked at this too. But again, the beauty of just how simple this is, right? Like there's just a main cleaning and build code and an analysis code. I should have separated the cleaning and the builds, but I wanted to show that just the simplicity of setting my globals. And this was just for an RCT. So there wasn't a big set of data. It was a rather small data set, but it was kind of very elegant. And this was something that Dime Analytics helped me with. And again, something very simple is for each one of the aspects of my code. So building baseline, cleaning baseline, cleaning end line. For each one of the processes that I was doing, there was a clear sort of description, input, and output. And so I think, again, these are small things that everybody can just easily implement in their own work. So the second thing that I mentioned as being a benefit was confirming the validity of your results. As I said, there's nothing worse than submitting a paper that you then have to kind of change. And so as you can see, that this has happened to me, right? Table 1 did not reproduce as shown in the paper. Glad I caught that before we sent it off to the journal. And similarly, when I said, there wasn't the right number of tables. So for this particular paper, we produced some additional tables and we appendixed other ones, and we weren't very streamlined in how we did that. And so again, what came through in the reproducibility check was that these two tables could not be verified because they weren't found among the outputs of the code. So there was sometimes the discrepancy can go both ways. The paper has something, the code didn't have it, and vice versa. So here are, I don't want to kind of belabor this. I just want to, these are all from my own experiences, and the emphasis that I want to really place is on it's a bit of a learning process to get to the point where you get fewer and fewer of these errors. And I think Luis Eduardo can attest that the second time I did this was much better than the first time I did this. And so it can be a very helpful and as Ben was saying earlier, as you do this process, you learn to set up your code in a way that you don't get as much of these errors. Okay, so my last slide, and as I said, my part is relatively brief because the goal really is just to emphasize how much this process has helped, and then has helped me improve the coding process such that the reproducibility turns up less and less. And so, as I mentioned, the first time I used this was for the JDE pre-results, and so we already had reproducible cleaning and building code by the time we got the final data. And because we had pre-specified regressions, it was literally a matter of, I've never written a paper more quickly in my life. Like it literally was in the span of like 2 months, we got the data. I remember this because we had a presentation 2 weeks later. And so we got the data, we'd already gone through the reproducibility for the cleaning and the build. And all the variables at endline were the same names as at baseline. And so it just went extremely quickly. And so I highly recommend it, even when you're thinking about going through the pre-results JDE process. The second thing, as I mentioned earlier, was with this RCT that we submitted recently. The whole process with the journal took less than 3 days, like a week to 3 days, 3 days to a week to have it kind of finalized. And then the last thing I want to mention is for administrative data. So there's a set of projects that we have that work with big companies where we've signed NDAs and we can't provide the data to the journal, but it provides assurances to the journal to know that the results are reproducible, even though they don't have access to the data. And the way we the way we dealt with this is the NDA was signed with the World Bank. So your peers, Luis Eduardo, who's within the World Bank, is covered by the NDA. And so this is something that can be done, within an institution, for example. And I think that's it from my side.
Great, thank you so much, Sharon. So now we wanted to open for Q&A with anyone in the panel. So please feel free to unmute yourself and ask us questions, or ask them in the chat, and we'll all be happy to discuss further on any of these points. And I believe we've answered all of the questions that have come up in the chat, but if there's anything that we missed or didn't get answered fully, again, please jump back in with that as well.
I'm gonna take my prerogative of introducer and go with the first question. And first of all, super exciting panel. We were talking off camera before that we have not seen DIME in 3 years, and it's really great to see how much work has happened at DIME. So it's always great to see that. I have a billion questions, so I'm just gonna semi-randomly choose 2. So for Luis Eduardo, basically you showed us that I think it was a third that passes on the first pass. So it was like a third or 50% or something like that. So could you use that, or would you use that as a prior of like the reproducibility rate of research outside of DIME, given that as Maria was mentioning at the beginning, not many institutions have this support, so there's no such thing as a check, and you're saying that a third or 40% passes. Would that inform your beliefs about reproducibility in other organizations?
Actually, I remember a few months ago, we gathered information on how, because as in a first pass, it looks like it's a low percentage, having only a third of projects passing a reproducibility check, which is also, you would think that it's something that obviously all research should have, right? But there are some papers that do this across a number of published projects in economics journals at least, and they obtain fairly similar results. Like around 2/3 of published works don't pass basic reproducibility checks. And with basic, what I mean is that someone else who is running the code in a new computer is able to reproduce what the paper shows. So this is very much in line with what you see in, at least in economics research.
If I could, if it's okay for me just to make a point, first of all, I just want to really applaud everything that you all were discussing and all the progress you made, and just give a little bit of a kind of big picture. Just listening to Erin's talk about, going through pre-results review, having all computational reproducibility checks, for a pre-registered study, et cetera. BITS is only 10 years old. It was actually less than 10 years ago we had our first meeting. All of those concepts and all those words you talked about would have been completely foreign. Like no one would have understood them in development economics 10 years ago or 8 years ago or 6 years ago. So to think that within that very short amount of time, all of these things have been mainstreamed. They're like improving the quality of your work. Erin said, it's like papers are being written up quickly. We're catching mistakes. And the fact that a group as influential as DIME has brought all these practices on board and just mainstream them is like amazing to me as someone that, is just thinking of the last decade of progress. So, again, I'm just really moved to hear about all the progress that's been made, and really excited for other organizations to follow your example. And, anything that we at BITS can do to facilitate that, we will, and we're already, brainstorming ways to do that. So just, huge congratulations. And again, I just wanted to step back and say, wow, what a change in a small number of years.
Thanks so much. I think we're also really excited about how quickly it feels like things are changing, more broadly across the field, but certainly within DIME, it's been, we've really been surprised by how much, we can get pretty widespread traction on some of these practices and ideas, and it feels like a promising direction.
I have a sort of half-formed question, which is that I feel like there's a subtle distinction between reproducibility and reusability. And like when a researcher is looking at another researcher's code, they usually don't want to just reproduce it. They want to do something new that builds off of the previous study. So like, have you ever encountered situations where you have to choose between reproducibility and reusability, and like, how do you prioritize those?
I certainly don't think of those as trade-offs. I think that the reproducibility is kind of a minimum standard for reusability, that you want to make sure that for example, that the code you're releasing that goes with your paper, like actually reproduces your paper, so that then somebody could take that and apply it to a different sample or apply it to a different context, different country. But if they're not able to even get the same results you did using the same data, then they're not going to be able to get those same results using other or similar results using other data, right? If things are not working. So I think of it just kind of as a reproducibility as a minimum bar, and very much our goal in one of our goals in making our research portfolio more reproducible is to facilitate that reuse and to encourage that reuse, so that studies are replicated in different contexts or with different samples. And we just think that having code that we know works within the particular study context is a minimum bar to then having further reuse.
Is it okay to just jump in?
Please.
I really wanted to applaud this work and to sort of echo the comment that was just made about the progress in the last 10 or so years, and just to comment that I've been working with the political science community, specifically local here at Yale, and we've been seeing the same kind of progress and the same sort of adoption of these practices and these principles. And so it's really great to see this, across the different disciplines and across the different, in different scholarly communities. I just wanted to also mention that we have a group of folks who are trying to gather these sort of practices and learn from each other. So really share the different practices and establish some standards along the line of how do we review and verify computational reproducibility. So there's a group at the Research Data Alliance called CureFair that is doing this work, and there's Cure Consortium. So I would encourage anyone who's interested in reaching out, and I'm happy to be a resource for that too, because I think that there are really exciting developments in the social science specifically that we can all learn from each other. But again, thank you. This is tremendous work.
Thank you, and we'd love to discuss how we could collaborate further and join that community.
There was a point I wanted to comment on. It's the first question that we received about developing resources for proprietary software versus open source software. And well, apart from what Maria mentioned in the chat, I would say that definitely advocating for the use of open source software is something that our team also does in the World Bank. And in that sense, we have a very big, I would say, a very big restriction on the capacity of the team that does the research. What usually happens is that the principal investigators of the projects know this other software, and yeah, that's why teams in general prefer to code this data. That's in practice what we observe, and that's why almost all of our resources that we've developed are dedicated to data, because we also have to tailor to what is happening in our team and our department. That said, as I said, we are also advocates for the use of open source software. And in that line, we have developed a couple of pre-trainings that we conduct in our team and also more broadly in the World Bank that are supposed to encourage the use of especially R and Python. And these trainings have open access materials that anyone can access. And the materials are designed to be self-explanatory. So you can, I'm going to share the repositories of the materials in the chat. So if you want to take a look at it, yeah, you can. And also the materials have an MIT license, so you can also modify them for your own use. And yeah, for the sake of more use of open source software.
I think we are pretty much out of time, Fernando. Is that right? I put our the DIME Analytics email address in the chat. Please, everyone is welcome to send us any questions, comments, requests to, or invitations to collaborate. We'd love to keep continuing the conversation. So please do reach out to us there.
Yes. Yes. Thank you very much for such an amazing presentation. I really enjoyed it. Hope others did too, and please join us next time for our third session on November 17th on hash linkages for administrative datasets. I think that could be a nice follow-up to this type of conversations where the challenge is how to achieve reproducibility when we're working with data that we cannot share publicly. So it's going to be another exciting presentation. Looking forward to see you there. Thank you.